In this product tour, we'll show you how we're enabling enterprises to unblock their AI projects that are typically delayed due to difficulties operationalizing siloed data, slowdowns and errors from the need to anonymize or tokenize data to comply with privacy restrictions and regulatory FUD. With Opaque, enterprises can unlock the value of their confidential data to get rich insights securely, quickly, and easily, and most importantly, accelerate their time to value. All users in a team are added into an organization, which enables shared work on the Opaque platform. A subset of the users can be given the organization admin role, which enables those users to granularly manage access and perform other controls on the entire organization. Once users join an organization, they can be given a variety of other roles. To operationalize proprietary or confidential datasets, users first encrypt their data at source with a unique key, and then share access to that encrypted data on the Opaque platform. By default, access to the encrypted data is available to all other members of your organization, but this can be configured. When sharing access to the encrypted data, you can define which attributes or columns of the data you want to share by simply clicking a few boxes. We've heard that this simple UI has saved our partners up to 10 months of time, because they no longer need to have a different team within their company anonymize or scrub the data. To work with other teams on the Opaque platform, you can create a workspace to collaborate with other teams. In this workspace, we have two users, Alice from the organization Cabrillo and Bob from the organization Atlantis. To operationalize siloed data, you can then share your organization's data with individual workspaces. Similar to how access can be initially configured, you can also configure what parts of the dataset are shared with a particular workspace. And all of this is cryptographically enforced by our policy engine. For this workspace, we can see that Alice and Bob have each shared multiple datasets. Once a dataset has been shared to a workspace, it can then be used in a job. In Opaque workspaces, you can securely operationalize your and your partner's data using jobs. In this tour, we've defined a number of sample jobs for a variety of use cases. All jobs run on top of the secure, scalable, runtime engine we've built on top of confidential computing, ensuring confidentiality and integrity of your data while it's being processed. Workspaces support popular coding languages and frameworks for AI like Python and Spark. For this tour, we'll walk through a couple jobs written in Python. In this first job, the workspace is collaborating to perform what we've seen as a common use case across multiple industries. KYC, or Know Your Customer. In this use case, data is securely shared across teams to enable one team to get more information on their customers by essentially securely joining one dataset with another. As we can see here, the job loads both Alice and Bob's data before performing the KYC operation. This job, as you can tell, is written in Python and uses the default and very well-known PySpark DataFrame API. Before we move on to the second job, I also want to highlight an application of our policy engine. Here, we can see that for this job, both Alice and Bob had to explicitly agree to allow the job to be run before it could be executed. This explicit cryptographic agreement is required to ensure that your data is only used in ways that you explicitly consent to. In this next job, we're training a machine learning model on encrypted data. In this case, we're doing simple hyperparameter tuning to see how we can train the best model on some confidential financial data. We then save the model encrypted. This job is a good example of a common scenario we've seen, where one collaborator is responsible for training a model, leveraging the data of other collaborators. The model trainer owns the IP behind the model, and as a result, other data providers, even though they contributed data to the model training, cannot see the model. That's why Alice can't see the results of the job here. In this third job, we use the trained model from the previous step to securely serve predictions on Alice's data. In this job, Alice is providing data to perform inference on, and we're evaluating the accuracy of the trained model in the results. Note that the model trainer cannot at any time see the inference data that Alice is using. Before we wrap up jobs, I'd also like to show you our no-code interface. One of our missions here at Opaque is to make confidential computing accessible. While our notebook interface empowers data scientists to secure their workloads while using AI tools they already know and love, our no-code interface takes this a step further by enabling those that have no code familiarity to run jobs and operationalize data in a secure fashion. Before we wrap up the product tour, I'd also like to highlight one last feature: audit logs. What we've heard is that in addition to ensuring that data remains private, data owners want proof on how their data was acted upon. We took this request and built audit logs, but took it one step further by providing not only a normal audit log, but a verifiable audit trail, meaning that each audit log record is cryptographically signed to provide integrity. And this allows the data owner to cryptographically verify exactly what was done on their data. That wraps up the product tour. We just walked through how enterprises can more efficiently and securely operationalize their data, giving them richer insights more quickly and easily.